All right, geometry 6.2, properties of parallelograms. So parallelograms is another huge topic in geometry. Parallelograms have so many properties that we're going to discuss later. And again, we are going to do some proofs involving parallelograms. So there'll be a couple sprinkled throughout the next couple sections. So 6.2 through 6.5 potentially. So I'm not as hardcore as maybe the triangle proofs, but again, you'll see that those are going to be used in these proofs. All right, so what is a parallelogram? Well, by definition, a parallelogram is a quadrilateral with both pairs of opposite sides parallel, right? So it is a quadrilateral or a four-sided figure with both pairs of opposite sides parallel. Now, I want to go ahead and create this in Desmos geometry, and we're going to use Desmos geometry to verify a lot of the properties we talk about today. So if I want to make a parallelogram in Desmos geometry, and I invite you to do the same thing if you want to, I'm going to start with a segment. Okay. And I'm going to create a parallel line. So let me put a point down here. More tools, parallel line. To this side, through that point. Okay. There. And I'm actually going to slide this point outward. Now I'm going to connect these two with a segment. Sure. And now I'm going to create a parallel line on this side going through that point. More tools, parallel line to this segment through that point. And now I'm going to box in my parallelogram with a polygon like so. 1, 2, 3, 4, and back to the beginning is 5. There's my parallelogram. I'm going to hide these lines, and there's my parallelogram. I'll make it, that's fine. Let's call it A, B, C, D. So A, B, C, and D. I know I constructed it to be parallel. Let's just double check that they are parallel opposite sides. So let's go ahead and make a diagonal AC. And let's measure our alternate interior angles. So let's measure angle DAC and BCA. So if lines are parallel, all alternate interior angles are congruent. Let's do the same thing here with BAC and DCA. And again, same thing. If lines are parallel, then the alternate interior angles should be congruent. All right, so I'm going to go ahead and hide those measurements because I don't really want them right now. Okie doke. All right, so now that I have them hidden, so there's my parallelogram. So let's talk more about the other properties. So let's go back to our notes here. Okay, so we need to know how to identify the opposite sides. Well, when you talk about opposite sides of a parallelogram, we're talking about the ones across, right? They don't share vertex. So AB and CD are opposite sides. It should be kind of self-explanatory. When we're talking about opposite angles, it's two angles that don't share a side. So angle A and angle C are opposite angles. They're diagonal from each other. Okay. Now, to abbreviate parallelogram, you will see this symbol for a parallelogram. Okay. So be aware of that. So this would be parallelogram A, B, C, D. Notice I go in order like this. A, B, C, D. You don't go A, C, B, D. You don't crisscross. You go circular when you name a quadrilateral. Okay. Cool. All right, so next property says, if a quadrilateral is a parallelogram, then the opposite sides are congruent. So for a parallelogram, your opposite sides are congruent. So we have this picture right here. So let's just double check that in Desmos geometry. So if I come back to my drawing, let's just go ahead and label AD 3.29, BC 3.29. Let's label AB 5.79. Let's label CD 5.79. Opposite sides are congruent. So parallel, opposite sides, congruent, opposite sides. Next idea. Okay, so now we need to talk about consecutive angles. So consecutive angles are angles that share a side. So, for instance, angle A and angle B share side AB. B and C are consecutive, C and D are consecutive, and then D and A are consecutive. You have 4 pairs of consecutive angles. Now, notice here, The theorem below uses the fact that consecutive angles of parallelogram are same side interior angles of parallel lines. Think about this. If AD is a parallel line and BC is a parallel line, then that means AB is my transversal. Angle A and angle B are both on the bottom of the transversal, and they're in the interior between the parallel lines. They are same side interior angles. And from our parallel line talk, same side interior angles are supplementary. Very good. So in a parallelogram, your consecutive angles are supplementary. And again, there's 4 pairs, right? 4 pairs. Let's take a look at this in Desmos geometry just to verify. So I'm going to measure all my angles. So let's measure A, B, C, and then B, C, D. 67, 113, they add up to 180. CDA, 67, DAB, 113. So again, each pair of consecutive angles is supplementary. All right, next. 2 more ideas. The next one says, if a quadrilateral is a parallelogram, then your opposite angles are congruent. So again, we talked about opposite angles. Here's your picture. A and C, B and D are congruent. If you look back here at my Desmos geometry, that's already done for us. A and C are 113, B and D are 67. Opposite angles are congruent. And then last but not least is our diagonals. So notice that my parallelogram has no diagonals drawn, but you can easily draw on your diagonals. The diagonals are just AC and BD. And in a parallelogram, the diagonals bisect each other. So notice here that AC is broken into congruent parts and BD is broken into congruent parts. I want you to be very clear. Segment AC is not congruent to segment BD. The diagonals are not congruent to each other, but the parts that they're broken into are congruent to each other. So BE, DE, AE, CE. Now I'm going to try to do this on Desmos geometry, but this is tougher to do. So bear with me as I go through. Okay, so I'm on here. I'll draw my diagonals. So AC, BD. So I'll go ahead and label that point E in the middle there. Okay, so now I'm going to try to make segment AE and measure it. So it keeps clicking on the big. So give me some time. Let me pause the video. Okay, so as you can see, I have labeled AE and CE. They're both 2.71. Remember that AC is just double that, or you add the 2.71s together. Let's see if I can get DE to do it on the first try. Let's see how good I am. Nope. Nope. All right, let me pause the video. Good. And there you see that for DE and BE, they're both 3.85. And again, what's nice about how I constructed it is that if I should be able to move vertices and nothing, the relationship stayed the same. So the side lengths might change, right? But the relationship stayed the same. So if you take a look at, say, what if I stretch it out like this, right? Opposite sides are congruent. Diagonals still bisect each other, and these opposite angles are congruent. Consecutive angles are supplementary. So lots of cool things involving parallelograms. All right, so I make a video covering, I think, a proof going along with parallelograms. All right.